We are going to see how to use H2O AutoML services for tabular use cases. For this, we will primarily use our award-winning AutoML tool, Driverless AI. First, we're going to see the many ways we can connect and upload the data we are going to use for machine learning model building. Through automatic visualization, model optimization, customization, whether that's of the features, the models, or the scorer to optimize, and finally, the creation of automatic and portable scoring pipelines. Let's get started. My AI engine is the engine manager to host Driverless AI or H2O free AutoML tools. Each instance can be scaled to accommodate the size or the type of models the users would like to build. Let's open Driverless AI. We can directly see the datasets available to the user. We can choose to add more data, whether this is coming from S3 Amazon buckets, H2O Drive, Snowflake, GDBC, or H2O Feature Store, which we're going to look in a second. H2O Feature Stores allow users to store, update, retrieve, and share features with others, specifically in the context of machine learning models building. The users can explore, search for features, check for metadata, tags, and type of data they would like to use. They can reuse feature sets derived from user transformations or Driverless AI automatic feature engineering, which are stored themselves in derived feature sets. Both online and offline feature stores are available to allow for large-scale or low-latency data retrieval. Permissions as well can be set on feature sets or projects in order to modify and control the access to authorized users only. This can be particularly useful when dealing with sensitive information in the data. Let's get back to our data sets and let's visualize it. In the Auto Visualization tab, we can see many different visualizations being created for datasets, whether this is the correlation graph to see correlation between the columns we have available in our features, outliers, disparate box plots to visualize the distributions of some of our features against others, and we can also create further feature generations with different types of charts and variables if we want to. In addition, we can also see an overview of all the columns we have available here, and as well as the churn distribution, which is our target column here, what we're going to try to model. Let's get started. When trying to predict and build a model with Driverless AI, depending on the user's persona, we have two options here, Predict and Predict Wizard. Predict Wizard is suited for users that are not data science or machine learning expert, but would like to be guided through that process. Let's get started with it. The Driverless AI Wizard lets you choose which persona you best correspond to guide you accordingly through the model building process. Let's pretend that we are a novice user. Driverless AI gives me some information about the datasets we're looking at and prompts me to find out which column I would like to predict. Here, I want to predict customer churn. I know it's between 0 and 1 and correspond to a binary classification. It tells me that no sampling is required and gives me the distribution of the target column. Target column, which is highly imbalanced, only 14.5% of my customers have churned. Although this is in balance, Driverless doesn't recommend necessarily to use imbalanced models in the model building process. It founds an ID column, which is usually not necessary and shouldn't be used in the model process. I will drop it and ask me for further column checks to drop. Driverless AI is also checking for data leakage. That is data that would not be available at time of prediction and therefore would not be useful for the production phase. Those would be usually holding a high predictive power in the training phase, but not in the production phase. Here, no data leakage is detected. Finally, we can choose the sort of objects we're going to get at the end of the model experimentation. And if we're not ready for production, we can decide later. Depending on whether or not we would like to reproduce that model training, we can also choose to be on the same hardware later on. This is not a time series problem here, and no date or datetime columns were found. Here, I know that each row of my data sets correspond to one customer, which are in theory independent. We can check that rows are independent. For best data science practices, it's always recommended to use a test set on which my model training will be tested against. Here, I don't have a test set created, so let's create it. A good rule of thumb is to select 20 to 30% of the original training data set for testing. Let's keep 20 here. Let's confirm it. Finally, we can select the model type that we want. Here, it depends on our needs, whether we are wanting to privilege accuracy, but also interpretability and time. Here, it's a middle ground between having high accuracy, also high interpretability, potentially less complex feature engineering created automatically by Driverless AI, as well as a time that is limiting the experimentation. We don't want to limit that time, although we could. And we could also reduce the model complexity and size that we're going to get in the end. Let's keep it this way. Finally, we can choose the score we would like Driverless AI to optimize through the genetic algorithm. Here, we're going to keep the log loss. Let's give it this experiment a name. And let's start training. Once the experiment has completed, a few information are available to the user, like the final pipeline validation score, as well as the test score. The top variable importance here, total day charge, is the top contributor to customer churn. We have more details about the results of the model in terms of all the score, like log loss, F1, recall in the scores tab. In the notifications tab, all warnings and information that the user can use for future iterations are useful to tweak the settings later on. The user can now download the AutoDoc. This gives transparency about the methodology used in the final pipeline model, have a look at the validation strategy, model tuning, feature evolution, the top feature importance, and any information that may be important for governance purposes. Let's have a look at the scoring pipeline. Now here we can visualize the final pipeline that was used by the Driverless AI. We can download that scoring pipeline as a Python or Mojo file. Mojo is a portable and low latency model that can be deployed anywhere. Here we can download predictions, download summaries and logs, and we can also tune the experiments if we see fit. We could choose to deploy the model in H2O MLOps using the UI, but I will show this later using the Notebook Lab with a Python client for H2O MLOps. Let's interpret this model. I've already run interpretation for this model. This gives me the ability to check and interpret the model using the various tools to check out the Driverless AI model predictions with Shapley values. Let's have a look at interpretation of this model. This allows the user to interpret and explain the Driverless AI model predictions to be able to understand whether the model predictions are fair and whether the model is robust and understandable by the business users. For this, many tools are useful, from global and local explanations for Shapley values, sensitivity analysis, which are tools for what if. This is very useful when you try to stress test and check out the robustness when changing slightly some of the features or changing significantly the values of the features. Disparate impact analysis, which allow you to choose a variable on which to check the fairness of the model prediction for each category of that variable. This is very useful when you're trying to check out disparities within gender, for example, or race. Let's have a look at the partial dependence plot. Here, total day charge, which is our most contributing variable to the model, we can see that the larger the total day charge, the larger is the likelihood of churn for the customer. Without further ado, let's have a look at the custom recipe. One thing we did not mention here is the ability for the user to use custom recipe for transformation, as well as model algorithm or scorers. There is a GitHub repository here, available publicly for the user to show how to create a recipe, as well as example for scorers, models, as well as transformers. For users that would like to automate their training and scoring process, we provide Python client for MLOps, AI Engine Manager, Driverless AI and Feature Store, and more, which allow the users to use their favorite IDE or the provided Notebook Lab available here. Let's click on it. Different clients are already installed on my Notebook Lab. However, they are available on PyPy for any users to use it on their local machine or their favorite IDE. In that instance, I'm showcasing how I can connect to my AI engine or create it should it not exist already. I can connect to Feature Store and retrieve feature set as well as my feature set project. I can build a model in Driverless AI using Feature Store connection. Here, I'm listing all the available connectors that we've seen earlier in the UI demonstration. I can create the datasets using the Feature Store connectors again, and display some information about my churn datasets that I've already uploaded earlier too. I can run an AutoML experiment. Here, I simply have to give a few information about the name of the experiments, the train dataset, which is the one I've just created, the target column, in case it's a supervised case. If it's not a supervised case, then it's not needed. The sort of task, whether it's classification or regression, and then finally, some information about the accuracy, time, and interpretability. Those would have a default value, but in our case, we want to have a fast experiment being created. Once this has been done, I can deploy the model in H2O MLOps by simply creating a project and linking my experiments to this project. I can connect to H2O MLOps via authentication, register my experiment as a model within the H2O MLOps UI, and then I can create a deployment. We're going to see how it looks like in the UI. While the deployment is launching, it's not healthy, but after a while, I can see that my deployment is healthy. When it's healthy, I can make a prediction and try out my endpoint that has just been created. I can select a sample of the data that I need to send to that endpoint, and then send that sample request to the endpoint we've just created. Please note here my password is not very secure, but it's not something we would advise to our customers. In this case here, the output from the H2O MLOps endpoint gives me a score for each of the different class for churn, which is here a customer that is unlikely to churn. Let's have a look at how it is into H2O MLOps. I can now see the project and I can see the deployment that is in a healthy state.